So, imagine looking at your bank account and like 95% of your money is just invisible.
Yeah, I think I'd be calling fraud immediately.
Right. But the bank swears it's there. They
Yeah.
just call it, dark money. They have absolutely no idea what it's made of or where it's kept.
Just that their internal mass requires it to exist.
Exactly. So, welcome to the deep dive. Today, we are looking at a massive stack of sources you sent us, research papers, articles, and dozens of preprints from the Institute of Integrative and Interdisciplinary Research, or IIR.
It is a mountain of reading, but the core mission here is incredible.
It really is. Our mission for you today is exploring their wild claim that we can explain the missing 95% of the universe, what we usually call dark matter and dark energy, without discovering a single new particle. So, okay, let's unpack this. Where do we even start?
Well, to understand this, we really have to go back to a major theoretical misstep from 1967.
1967.
Yeah. So cosmologists had Einstein's cosmological constant, which is basically a mathematical placeholder for the energy of empty space pushing the universe apart. But at the same time, quantum physicists knew that empty space isn't actually empty.
Right, it's bubbling with quantum vacuum energy.
Exactly. And the 1967 mistake was just assuming these two things were perfectly identical everywhere.
Like assuming the vacuum of space is just this uniform, boring constant. But nuclear physicists looking inside a proton found that vacuum energy behaves very differently on a microscopic scale, right?
It does. It behaves completely differently on that local level compared to the massive cosmic scale cosmologists we're looking at.
So is this basically like two corporate departments, nuclear physics and cosmology, just refusing to share their spreadsheets for 50 years,
That is pretty much exactly it.
resulting in a universe-sized accounting error?
Yeah, that is exactly how the lead investigator, Boris Kriger, frames it. These fields operated in total isolation. And what's fascinating here is that when the IIR finally bridged this gap, they didn't need to invent any imaginary forces.
Okay, wait, so no new physics at all.
None. They created the local gravity of quantum vacuum framework, or αLGQV, by taking a single number derived purely from established nuclear physics, a coupling parameter called alpha, which equals 0.005.
Wow, just that one number.
Just that one number. And they could accurately scale up that intense microscopic energy inside the proton to explain the massive expansion of the entire universe.
Okay, so by just applying the nuclear math to the cosmic scale, it perfectly reproduces how fast the universe is expanding and how galaxies rotate.
Exactly. It solves the problem.
But I mean, math is just math. If this massive paradigm shift is real, it must have left some kind of physical footprint, right?
Oh, it absolutely did. The framework predicts that the quantum vacuum underwent a violent shift in the very early universe.
Okay, when exactly?
Specifically during the QCD confinement transition. This is the exact moment when loose quarks permanently locked together to form the first protons and neutrons.
Oh, wow.
And that sudden locking process should have triggered a massive burst of gravitational waves.
Like striking a massive cosmic bell at the dawn of time. And we should still be able to hear the echo, which brings us to the NANOGrav collaboration.
Yes.
Because they recently detected a universal hum of gravitational waves filling the universe. Initially, didn't everyone just assume that hum was caused by distant, supermassive black holes crashing into each other?
They did, but the black hole theory is messy. When you look at the NanoGrav data's spectral shape, essentially the unique fingerprint of frequencies making up that hum, it doesn't perfectly match black holes.
Doesn't quite fit.
Right. Astonishingly, the precise frequency fingerprint predicted by the alpha-LGQV framework's primordial bell ring matches the NanoGrav observations far better. It's literal gravitational archaeology.
Okay, wait, I have to push back here. Did they just look at the NanoGrav fingerprint and massage their math to fit it after the fact? Because predicting the past is incredibly easy when you hold the answer key.
That is a very fair point, and it's crucial to ask, but the timeline absolutely clears them.
Oh, really?
Yeah. The predictions for the frequency and strength of those waves were locked in and published before the NanoGrav data was ever even compared. 0 adjustments were made.
Man, that is genuinely impressive. And what really stands out in your stack of sources is how aggressively transparent this team is. Kriger explicitly says there is no new physics here. The formulas are from established literature.
Yeah, they aren't hiding behind proprietary math at all.
Not at all. They've dropped 37 preprints, open sourced their code, and submitted their work to Nature Astronomy. They even mentioned the engagement of heavyweight physicists like Professor Stanley J. Brodsky.
Though, to be fair, they carefully note he hasn't officially endorsed the entire framework.
Right, right. Important distinction. But still, the transparency is wild.
Well, the ultimate sign of good science is vulnerability, right? This theory is strictly falsifiable.
Meaning it can be proven wrong.
Exactly. They have drawn a line in the sand. If anyone, anywhere, physically detects a single particle of dark matter, this entire theoretical framework falls apart instantly.
So the big takeaway for you listening is that unlocking the universe's deepest secrets might not require inventing new physics. Sometimes it's just about tearing down the artificial walls between different scientific disciplines.
Absolutely. Synthesis can be just as powerful as discovery.
Which leaves us with a pretty heavy thought. For decades, we have spent billions of dollars, built massive underground detectors, and dedicated entire scientific careers to physically capturing a dark matter particle.
It's true, an immense amount of effort.
So if this theory is right, what happens to the thousands of brilliant minds who have spent their entire lives hunting for a ghost that never existed in the first place?